Welcome to the May meeting of TriEmbed. Oh, Scott Hall is here. Sean, are you a first timer? And
Your
Yes, I
mic.
am.
and how did you find out about us?
I have been on the email list for a long time.
Okay. Well, welcome. Do you want to tell everybody anything about yourself, or just want to
Uh,
keep lurking?
a long time computer nerd. Been dealing with Linux since back in like 0.099. Studied computer engineering at NC State back in the late 80s. So have a plethora of projects that I every once in a while I want to start digging into to do some just basic electronic stuff. Never really have had time. Recently unemployed, so now I have some time on my hands to actually join some of these meetings and come to some of these things.
Well, we're glad you joined. All right. Any announcements?
We've got another fellow jitser here.
That's Scott Hall.
Oh, is that Scott? Oh,
Yeah.
okay. I
Scott
don't know,
can.
Scott. You look different for some reason.
I'm at work and it's just a different camera, different computer,
Oh,
different setup. I couldn't get home in time, so I figured I'd connect from here.
Okay. If you want to change your name, there's a way to do that. Following the dot 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 thing somewhere. So there was a Sumo Bot competition at the Forge Initiative last Sunday. No, a week ago yesterday. And I participated. That's what I've been doing for the past month or so. There were two divisions, one for robots that were built out of Legos and one for robots that weren't. I think there were 4 entries in the Lego division and 9 entries in the um, open division. They did a kind of a round robin in each division, and you get points for winning, and added up the points, and whoever had the highest score won. So I participated in 8 matches. I won 5 and lost 3. So I ended up in 3rd place out of 9. Was pretty happy with that. The teams were, most of them were like an adult and a couple of kids, middle school age, maybe some high schoolers. And there were maybe 3 of us or 4 of us that were adults with our own robot. The winner was one of the adults. His robot was pretty amazing. It was very fast off the line and would charge. I couldn't quite tell if he had his distance sensors working or not. Um, in the very beginning, you know where your opponent is because there's a certain spot on the court where you have to start. And so he would whip around and push towards where the robots were. But if he didn't get you on the first one, he just seemed to go off in random directions, which again worked fairly well because it was usually it's a relatively small court, and almost any direction you end up running into your opponent. So now I'm on to other projects now that I have some time back. So any other announcements? Things coming up? I can't think of anything.
They just had a train show this last weekend, but unfortunately I couldn't participate.
Was that at the fairgrounds?
Yep.
Yep.
But it wasn't the big one, so it was over in the Kerr Scott building.
Okay.
And yeah, there was um, I want to say not really pseudo robots. They were tethered, but there were some of those going on there, some animations. And of course, various electronics boards being used for various animations and control systems and stuff. So I got pictures. I just couldn't share them in time tonight because I'm on my work computer.
Okay.
But yeah, I played the saxophone at a concert this weekend.
Okay. So they did stream the matches on Twitch, and they published it on YouTube. If people are interested, I can send out the link to the video and the times at which my robot ran.
Sure. Why not?
Yes, that's a good idea, Paul. Send the link out.
Okay, I will do that.
You can put it in the chat.
Maybe I can do that.
While you're doing that, Nick and I haven't actually discussed this, as well. We were expecting to discuss this, but we haven't discussed it. But it's probably about time for another Edger meeting, Edger project meeting.
Yeah.
And my sense is next week would be a good week. What do you think, Nick?
Sounds like a yeah. Sounds okay.
Okay. And there's a lot of stuff to unveil and discuss and so on. So we'll be publishing
Some of it
something
actually
about
works.
that. Yeah. We'll be publishing details shortly to the TriEmbed list and the Signal group.
All right.
I got a question for the group.
Sure.
Anyone out there looking for some work?
What you got?
Possibly.
Where I'm working at right now, they're entertaining resumes and stuff. If you want to stop on by and talk to them, it's a place called Device Solutions over here in Morrisville. All embedded.
They're probably looking for full time though, aren't they?
They could accept some part time. You'd have to talk to them.
What type of work is it?
Pretty much what we all do. It's they develop boards and everything for other customers, and then once they get a design all worked out and stuff, they're probably mass quantities developed at that. Manufactured at that point. They got some pretty big customers and everything that they do work for.
Who do you prototype with? Same companies that you do bulk manufacturing with?
I don't know because we're doing development here, and we've got like a second spin of the hardware and what I'm working on.
Do you have any favorite tool chains?
Well, I've learned quite a bit here. They use Docker because they use what is that Microsoft product? VS Code on a Microsoft box to cross compile, cross develop, and then of course they're utilizing GitHub and stuff.
That's the software end. I have the feeling Pete was thinking more of the.
Yeah, I don't have those answers because I'm not in the hardware group.
Yeah.
I'm on the firmware side of the house right now.
What processors are you writing for? Cortex?
Yeah. Most of them are Cortex M0 oriented. From different manufacturers on different boards.
Yep. Okay.
Anyhow, shoot me an email or something if you're interested in getting a pointer to who to talk to, who to send your resume to.
Paul, what are all the numbers you put in the chat?
That is the time codes in the video at which my robot.
Okay.
Mine's the one with the red wheels. I found somebody clued me in to the world's best Sumo Bot wheels. They're from a company in Canada called FingerTech. FingerTech. They cater to the combat robot crowd. And they're nice. You can get different durometers, different stickinesses of the rubber around the hub, and
I was just going to ask about that.
so here it is, and I can squish them.
They're solid, huh?
Yeah. So they have this aluminum hub in the middle, and then they pour polyurethane around them, and you can order ones that are. This is, I think, a 20 durometer, and then they have a harder one, which is a 40 or 50 durometer, I think.
How similar to skateboard wheels are those?
These are not at all. This feels like
These are soft.
Silicone caulk, like bathtub caulk.
Yeah. Yeah.
So I was not at all concerned about getting in a pushing match with another robot, because I think I had I had a 99-to-1 gear ratio. I had these grippy tires, and so the ones that I lost, I was being pushed from the side, and we kind of pirouetted around, and I drove off the edge as opposed to being pushed.
You know what I haven't seen around here is a robot rollerball. I've seen a match in another town, and basically the robots are trying to knock each other off the track, and supposed to carry the ball, or it's actually kind of like almost like a bowling ball. It's so heavy, around the track, and then they're supposed to shoot it toward a goal, and of course the other robots are trying to block all the shots and stuff like that. But it's robot rollerball.
Never heard of it.
Is this like a bocce ball, about like that size?
Smaller.
Smaller.
Kind of
like a cue ball,
size.
a pool ball?
No, bigger. It's about baseball size.
Okay.
Oh, okay.
Wonder where they get it.
But it's out of a material that's not going to chip or break or shatter, because those robots are pretty rough on it.
When you said it was heavy, I was thinking of a bocce ball, because those are pretty heavy.
Well, in my head, I originally was thinking of like a cue ball or a billiard ball kind of a thing, but there is some sort of different material, because a billiard ball will shatter. I'll have to try to get some video from the guys up in Maryland to show you guys.
Okay.
So, Paul, your screen was up. Oh, it's back up again. It was up and then disappeared. It's back.
Yep. All right. Does everyone see my screen?
It's there.
Yep.
Okay. All right. So this month's problem of the month is kind of a design review. I've tried to, I have some ideas on how I'm going to build this thing, but I've tried to hide those from you guys so that I don't bias your inputs. So I want to do some machine learning stuff. To do machine learning, you need lots and lots of samples for the neural net to process, and they need to be labeled depending on which categories you're looking for. And it's quite a difficult task to get sufficient high quality data sets to train such things. I've been talking about pickleball in the past few months. And so what I want to do is I want to put some accelerometers in pickleball paddles. And I want to have, the goal is to have some kind of a neural net that can process accelerometer readings in a pickleball paddle and detect.
I'm just trying to imagine all 28 channels of telemetry that you're going to be collecting on that.
9 times 4, 36 channels.
Yep, I miscalculated.
Yeah. And so in addition to the, so I'd like to have a little neural net that can detect when a player strikes the ball, and perhaps some information about the orientation of the paddle, and whether you're putting spins on it or not, and how fast it was going as it struck the ball, and all kinds of analytics that you might imagine. And so, I want to get the accelerometer streams from the paddles. I want to have a video camera watching the game. And then I want to post-process the video to detect when the ball changes directions. In other words, when it gets hit with a paddle. And then cut the accelerometer streams up into little pieces and label ones that have a hit in them versus ones that don't have a hit in them, and use that to train a neural net.
What about velocity?
What about velocity?
In other words, your video capture, you can calculate
the velocity of
distance
the
and
ball.
time.
Yep.
And what you want to calculate there basically is the energy transfer from the racket to the ball.
That would be nice to have. Not necessarily a requirement to begin with, but yep. And so I started to list some of the issues. How do we get the data from the paddles to the place where the data gets stored? How do we have power for the paddles? How do we correlate the data streams from the paddles with the video frames? How do we store all this data, and how do we replay it, and probably a host of other issues I haven't thought about.
For power, I was thinking the same thing that they use in wristwatches, where it actually takes motion itself and generates a small amount of power, charges a super cap that you can then drain for your circuit.
Okay.
You could use one of those flashlights that has the magnet in, and when you shake it, it makes the flashlight run.
Yeah, I don't want to change the behavior of the players, so I don't want them having to sit there shaking their paddle between.
No, just the activity of them hitting the ball would be enough.
I see. Okay.
However, when do you need the data to start being collected, and when do you want it to stop?
I would say when I start the video and when I stop the video.
Well, what I'm talking about
at the beginning of a game and at the end of a game.
Okay, I don't think I was talking about that. So you were talking about powering the paddles, and Nick's idea was when you started to move the paddle would then turn on. However, at what point do you want to start recording the paddle movements? At the moment it hits, before it hits, when you want it to stop, at what point afterwards?
I want a 20-minute stream that covers the entire game. I want to be
I
able to collect.
why not just put an SD card and store it locally? And then take the, I mean, it's an added layer of complication you don't actually need.
Okay, an SD card in the paddle.
Yep.
How are you going to synchronize the
You send
data?
you send out a Wi-Fi. It's a you could use an ESP or any number of devices that have Wi-Fi connections. Send out a UDP. Everyone knows what time it is. Otherwise, you know, you're going to have a whole bunch of data streams coming in, and they're going to get confused.
So I am interested in more than hits. So I do want to be able to record. Let me stop sharing my desktop here. I do want to record data even when they're not playing, or after, after the rally has finished or before they start serving, for reasons I won't divulge at the moment.
And you want the video real time while they're actually playing? So the data stream being real time while they're doing the whatever it is?
No, it could be recorded to a SD card or a tape or whatever and replayed later, as long as we can synchronize them.
I think there are one of the issues you're going to face, I think, is that people are going to be running around and threading. So who is where is going to be an interesting question. I think there are some local positioning systems that might help you there. It would be very useful to know where somebody is when they're otherwise well, you know the hitting of the ball, but you don't know where the person is.
Okay. Right. So one of two people on each side can hit the ball, right?
Mm-hmm.
So we have to figure out somehow, whether it was player A or player B on a side that hit the ball, so that you can tag the proper accelerometer stream.
Mm-hmm.
So that's an issue, but I don't know if it's a big issue or not. There certainly are machine vision things that can track objects. I'm assuming the camera will be stationary, and the only things that are moving in the field of view is the ball and the two players. I'm willing to require the players to wear different colored jersey of some sort, if that might help.
If there are only two players, I think I was thinking more than two players for whatever reason.
There's two on each side, so there's four players, but
Okay.
the ball's only on one side of the net. It's not on both sides of the net. So only two of the players are potential hitters. Generally, I mean, there can be some weird things where player A hits it and it doesn't go over the net, and then player B hits it to knock it back over to the other side. You know, when he does, that's a fault, but he hit it, and so it's a valid data sample that could go into the training data.
I would suggest that you want as high a data rate as you possibly can get if you're interested in analyzing the swing. And if you're interested in analyzing that, store it locally. You can probably burst it out, but you need to buffer up a whole bunch of data. Maybe you can detect that it's not moving and burst the data then, but 120, 180 samples per second would not be unreasonable. And that's the technical term is a shitload.
Okay.
And you've got presumably nine objects with each. So you've got a lot of data. If the network starts to hiccup, if somebody, all sorts of reasons, to not it, and it's going to make the thing more complex to store the
Okay, so I can imagine if we decided to transmit in real time, I can imagine adding a couple of additional pieces of information along with our 9. So the data samples on the gyro I'm using are 2 bytes each. So 9 times 2, 18 bytes. I can imagine sending a counter that just counts packets as it sends them out so that I can tell when I drop packets. So that would be a byte. And then maybe the least significant byte of the millisecond timer on board. So we get some kind of a feel for, how fast the samples are coming. So that's more than 10 bytes. That's what, 40, 30 something bytes. So we're talking 2 kilohertz, 2 kilobytes from each paddle, kilobytes per second.
The gyroscope will give you the movement where it is. What are you going to do for the initial origin point?
Your cameras will give you that.
I was figuring that we would start the match with everybody putting their paddle on the ground, facing north. And, somebody would press a button on the console and that would start the video, and then people can pick up their paddles and start playing. So Nick, if you had to synchronize these streams later on after the fact, how would you end up doing that?
What I would do is to send out a UDP time command to everyone, and then store the actual time, and as many degrees of freedom that I wanted to on the SD card.
And how frequently would you send out the time?
I'd send out the time just once. You're going to be accurate. Within a half hour, you'll be accurate within a few milliseconds.
Okay.
I do have gyro sensors working on this stupid aardvark thing I'm playing with.
So I thought of putting up some kind of a display that would be visible to the video that included the time on it. And so that way you could look at a frame and at least a human could look at the number and read, what time it is relative to when the data sequencing started. At least according to one clock. It wouldn't be, the clock that's in every paddle would have their own clock. The camera would have its own clock.
I mean, you have relatively rapid sequencing events in the, presumably they're hitting the ball thing with the racket thing. That gives you a synchronization event if you have a camera. So you don't have to be dead nuts.
Yep.
Let's say the camera frames are going to be a 30th of a second unless you get a high-speed camera.
Right.
But there are numerous programs out there that will take and give you skeletonized people from a camera, running NVIDIA stuff, which I think you know something about. So you could you know within a 30th of a second, and you've got very, very distinct changes of direction and very, very distinct pings, even on the audio track, that give you synchronizing events.
Okay.
I don't think you're gonna slip in time frame.
Yeah, and I don't know how sensitive the training data, for sending a sample to the neural net, you're going to want, some finite sequence of gyroscope events.
Mm-hmm.
And somewhere in the middle or near the end, right, there is this spike that correlates with hitting the ball that the neural net is going to fire upon. And I don't know how sensitive it is to the position, within that that sample. And so, if the sample is, say, 30 30 samples in consecutive in time, and we get like 4 samples every 30th of a second, so that's like 7 frames of video, one of which would contain the hit. So getting it exactly down to a frame or a subset of a frame, I don't think is a requirement. I think if you can get, within plus or minus 1 of when the ball changes directions, you're going to be doing
And
fine.
if you're tracking the ball, the ballistics of the ball is going to be fairly deterministic after it's been hit. So
Right.
So you've got and so you're interested in the key event, which is the impact,
So should I set up multiple cameras if I'm going to go to
yes,
all the effort of
yes,
collecting this stuff? Should I
yep.
do 2 or
Now,
4 or something? One from each different views?
yes,
4.
more is gooder.
Okay.
Now I've been working with Dan Skypes on stuff that analyzes tremor disorders. I did a bunch of work at Mass General with this, and I have, he's got multiple sensors that arms, hands. He's not interested in the racket per se, but he has done a lot of work on skeleton models and
Okay.
the reverse kinematics.
Right.
So it's if you want a virtual person, I've done that kind of stuff, but years and years ago. He's got real models that do that, and it's a so it would be there's some overlap there.
Okay.
As I've got one of his, I've got maybe 6 motion sensors. I have a slightly different approach than he does, but he's interested in capturing a lot of data from and to try and work out what's going on with the tremors.
His is a little bit higher res too.
Yep. So there's overlap, and because of that, I've put those sensors onto the aardvark the ant as a and I've got plenty of ants that have SD cards on them. So if that's of any help to you.
Okay. Any
And
other ideas?
all of the ant code has built into it SD card storage.
Is that over SPI?
No, it's just I just use the SD card. I've been using ones. Some of them have the real cheap ones have the cameras built into them, and they're used for doorbell cameras. And so they've got an SD card, some spare pins, and you can throw. I don't know whether the video from the SD card would be of any use to you, but you could store real-time video from each racket.
Hmm.
And they're like $5 a piece from China.
Hey, off topic, can you send me a link to those? I've got a different application I need a couple of those for.
Okay, other ideas? Did you raise your hand, Carl?
Yeah, but I clicked the wrong button. It wasn't what I wanted to do.
As far as cameras, GoPros are $400 or something. Raspberry Pi camera is $30. I would imagine that there are things in the middle. What?
I just sent out a link to the $5 doorbell cameras that so you can get from
AliExpress, yeah.
Yeah, AliExpress, and they have there are some for $11, but they have built-in cameras, which are not great, but and I wouldn't if you got impact, those connectors, you got some things going on, but
I wouldn't put these on the paddles. I'm just looking for collecting video.
yeah, but
of
it's
the matches.
for $6 you could get some of these things and collect the video, and you could get a lot of them for the price of a GoPro.
Funny, we just threw away a bunch of those over at the Makerspace.
Okay.
We had a donation of about 200 of them, and they just threw a bunch away.
I probably have 50 different cameras sitting around me.
GoPros you threw away?
No,
the kind of cameras that Nick just posted up from
Yeah.
Alibaba, and also the circuit boards that they interface to.
Yeah, I've got telescoping cameras with gigantic lenses, cameras with little lenses. all sorts of cameras.
Yeah, I'm just looking to bury them inside model trains.
Okay.
Which, by the way, Paul, some of what you're looking at, I could use telemetry activity from those model trains too, in a kind of a simulation, autonomous type of operation kind of a thing.
This is one of those the little $10 cameras on a big ass lens. And I have bigger lenses.
I did put one on an eyepiece at my telescope.
Did that work?
Yeah, I got some really good pictures. The various conjunctions that we had this spring. I wanted to see the rings on Saturn, and I even got the Jupiter's look like rings. They're not rings. But
it's going to be of some help to you in analyzing the data if you put down masking tape grids on the floor.
Okay.
Or some sort of gridded idea, like you
Yep.
know how you see with Mythbusters when they had the striping type patterns.
Yeah.
But the
And
About
grid,
marker-
the grid helps you find position.
There are
Well-
lines on the floor for, you know, the basketball plus the pickleball court, the basketball lines, but not that are of known spacing and stuff.
It will just be useful in terms of analyzing the data to be able to it will help the system if you, particularly if you're using a neural net to do the to analyze the video data. The more information you can get at that, the happier it will be.
Okay.
How about some sort of markings on the paddles themselves, like they do for 3D animation capture, motion capture, where they put like little dots on the people, the crosshairs on them?
Okay.
Crash test dummy target style things.
Yeah.
And you could do different colors or something, so the foreground and background person, when you have two people on the same time, to help it decide which one is which person.
If you got real excited, you could put a little blinky LED on the tip of the racket, and that would give you a good time synchronization.
Okay. Yeah, that's a good idea.
As long as you didn't hit it.
Yeah, that's always a problem.
No, you just embedded in some epoxy on the within the one of the holes on the edge of the racket.
Yeah, maybe I'll put something on the net that blinks so that we can synchronize the multiple camera streams.
Well, even a blinky light somewhere on the court, a fairly big blinky light, would let you synchronize camera streams too.
Only if they were all looking the same direction, right? I'm assuming these 4 cameras are looking in different directions, right? One
Well, they're all going to be
north-
looking around the net.
north, south, east, west from outside the court.
You also might want to make that blinky light a pattern of colors so that you can tell exactly when in the time stream that you're at.
Mm.
Yeah, it doesn't have to blink at a constant rate. Okay, these are all good ideas. Anything else?
Do a series of 8 of them and blink them in a binary pattern.
I mean, I would imagine that we'll be able to get within, you know, a half a second or a quarter of a second pretty easily for the video streams. It's getting that last little, you know, 30th of a second or 15th of a second that's the hard part. and you're only sampling at 30 hertz. They're not going to be perfectly in phase. You're going to be somewhere between. They're going to be interleaved somehow.
Some of the cell phones have very good high resolution and fairly good high speed cameras that might get you up to 120 frames per second.
Yeah, I don't have 4 of them lying around.
Having done a little bit of motion capture, you want a lot of data.
Yeah. All right. Any other ideas?
So
Okay.
your aim is to have an entirely virtual pickleball game?
No, not at all. That's no fun. At least not for me.
Oh.
I want to be able to recognize gestures, right? So I want to automate scoring. No, not those gestures, Nick.
This is a kid show, Nick.
I'm sorry, I'm a kid too. It's
Carl,
you
you're
can't
just gonna have to
automate
pixelize
gestures.
those frames.
You could send out a finger when somebody does something stupid. I mean, I have a different interpretation of what you said.
Right. Right.
I'm sorry, it's just the way my mind works.
I know. All right. All right. Well, thanks for all that. That's some.
What I was thinking is as you do some of this, you're wanting to improve a person's hit
Potentially,
and
yeah.
hit direction and aim, and
Reaction time, position while they're waiting for the shot. There's just.
But I was
just all
also
kinds of
thinking in
things.
terms of training.
Right.
So you kind of build up a model of what the ideal is, and then you analyze where a person is at. You want to get them to the ideal. It's not going to happen instantly. Your AI then can say, work on it from this direction, or these movements, that kind of thing.
Yep.
I'm thinking the way that they analyze, like say, a sax player, and to improve sax playing.
Okay. I didn't know they did that. I know they do that for professional athletes, all kinds of ways. Golf swings and. All right. Start. How do I stop sharing? I see a start sharing. Oh, I'm not sharing.
You're not sure.
Duh. All right. Show and tell. So I ended up making 3 circuit boards for my Sumo Bot. I'm going to power up my USB microscope camera. So this is my line sensor, color sensor. It's a small infrared LED and a detector, infrared detector. The one that you can kind of see is the LED. On the back side are a couple of resistors for current limiting the IR, the LED, and one other for doing something with the photo transistor. But I don't understand how Osh Park can charge me $1.87 for 3 of these, and they spend, at least 63 cents for the stamp, I would imagine, and little padded envelope, and they pay the person to break these apart and find 3 that match and stick it in the envelope to mail it to me. But so 60 something cents for that little circuit board.
So less than $2 for 3 of those.
Yeah, $1.87 for 3 of them. I ordered 6, so it was $3 and something.
I used to make some really small boards, and I really had a serious guilt trip.
I know.
And the only way I could think of to compensate was to just order a bunch, like, because
Did they all arrive in one envelope, or did they send them in separate? Oh, that's good.
they
Good.
did, and but I just went off the wall. I mean, in fact, well, some of the boards I made for
Those
Dan
your little
were
breakout
this.
boards for.
Well, they were the size of a small fingernail.
Yeah.
With a an itty bitty sensor and some other stuff, but yeah, I would order twice as many just because they were
Yeah.
they were like 25 cents a piece or something.
Yeah. Yeah. So this one is this was $6.60 for 3. It's a D1 mini shield. Got breakout for I2C pins. There's a buzzer there. You can see a couple of transistors. Those are for doing level conversion between the 3.3 volt ESP8266 and the 5 volt Arduino. And then there was a little header there for the servo that steered the my infrared distance sensor. And then this is more of a full-size Arduino shield. Whenever you're doing robots, I have found that it's a good idea to have a voltage regulator, because you tune your code for how many milliseconds it takes to spin 180 degrees, and then your battery drains by a tenth of a volt, and that constant changes. So I was running off of 18650.
That's when you want to set the using the internal reference.
The internal reference. The motors don't see the internal reference, right?
Well, if you're using any of the A to C's, you can measure against the internal, like a 1 volt reference or a
the
2.5 volt reference.
The issue is the voltage being provided to the motors, not the GPIO pins, right? And so generally you run the motors straight off the battery, and then that battery goes into the power regulator that's on the Arduino board. So the Arduino sees a constant voltage, but the batteries see, the motors see the battery voltage. And so you tune it at 1 voltage, and then you compete it at a different voltage, either higher or lower. And all your fine-tuned constants are not quite right. So I always put in some kind of a voltage regulator. So I was running off of 2 LiPo batteries, 2 3.7 to 4 volt. And so I had a 9 volt step up boost converter that I got from Pololu. And so I ran my motors off of the 9 volt, which was stepped up from the 7.5 to 8 that was coming off the batteries. So that's what plugs in down here. The motor control shield that I was using used almost every pin on the Arduino Uno. I think there were 3 pins left, and I wanted to do a bunch of sensors and things. So you can see this chip down here is a MCP 3008, which is an 8-bit analog to digital I think it's SPI interface. Yeah, so I used up my available pins to talk to this, and then I could
I
read
think they make
eight
those
different
in,
channels.
I think they make them both in SPI and I2C.
I2C. Yeah, I forget which maybe I2C that I used. I'd have to look it up. So some of them, so I have a spot here for putting on a pull-up resistor. So 4 of these I soldered in my pull-up resistor, and 4 I didn't. So I ran my line sensors off of 2 of these. I had 2 line sensors. I had a user input switch for starting the match, which plugged into one of these that was pulled up. I had a couple of switches to detect when my snowplow on the front was pushing against something. So a touch sensor to feel that I was engaged. And so they plugged into a couple of these, and then my infrared distance sensor also plugged into here. So it has power ground and an output which is proportional to the distance that it thinks the closest object is at. And then the motors soldered into these 2 pins. That was the motor controller pins. These were a couple of spare I/O that I didn't end up using.
Did you use 10K pull-up resistors?
I think so. These are just switched to ground. So it doesn't really matter what you use, but yeah, I think I used 10Ks. So I laid out my first version of the Arduino Shield. Let's see if I can get my camera working again. Let me unplug that. Hey, it works. Yeah, so I use Eagle for my board layout, and I pull in an Arduino as a part.
You're still sharing, by the way.
Okay. I pull in an Arduino Uno as a part, and then I lay out some connectors and kind of put them on top of where the pins on the Arduino are. And then at the end, I delete the Arduino. So I ended up with 2 of my 8-pin connectors. No, one was a 6-pin, 6-pin and 8-pin flipped 180 degrees. And so my analog A0 through A5 were the wrong way around. And so that was easy to fix in software. I just changed the pin assignments. The other one was VN ground +5 and 2 other no connects. So when I flipped that around, it ended up shorting ground and +5 on the Arduino. And so whenever I plugged my shield in, so I did some
Power
rework.
supply overheat?
It didn't. I didn't burn out the Arduino. I burned out a
The
bunch of,
regulator would have shut off the power.
yeah. I burned out a bunch of ESP8266s for some for known reasons, some for unknown reasons. One time I had just a little wire that flopped over and touched on the the battery. I think it was the battery. Maybe it was the 9-volt. So I fed 9 volts in, which I wasn't happy with. I saw the smoke on that one. Yeah, so I did some rework and got some traces on the board and moved some, put some bodge wires on and got it working, and then relayed it out and did a second copy of that one. I did a second copy of the the D1 Mini Shield as well. I don't think I made any errors on that one. Just added some functionality. I wanted some of those where I had extra GPIO signals. So I had them, and I had, I think, ground next to them, and I wanted power ground and signal so I could plug in additional servos or sensors or whatever. But all in all, I was happy. I felt sorry for some of the other teams. There was one team where their robot would drive forward, come to the white line, stop, and just sit there. So it would run forward for 2 seconds out of a 90-second match, and it would just sit there waiting for somebody to come around and push it off the board.
In the order of things, that's slightly less than Elon Musk blowing up a rocket. So
And it's all learning experiences, right?
yes, but some are more expensive than others.
Some are
Yeah,
more.
and
Or digging halfway to China with the rocket flames.
well, he kind of ruined the countryside around that rocket too.
Yeah, that was a major mistake.
Yeah. Well,
So
it's,
crossing a couple pins in comparison to that is trivial.
yeah.
People have told me I do very well if that's the only issues I had. So there you go.
I had an episode once where I was driving a FET transistor with a signal generator, and I turned the wrong knob and increased the duty cycle on the gate, and all of a sudden the oscilloscope trace stopped being reasonable, and I looked around and the FET had disappeared. There was no FET on the board, and it was because it had unsoldered itself and jumped off. And that was just, like, it didn't, it saved itself from the magic smoke escaping. I thought it was, quite cute, but yeah.
I'm sure it still died though.
Yeah.
I don't think so. I think I soldered it back on, but I mean, it was a really fast situation. I don't recall. It might have killed it. I don't remember.
I'd find it hard to believe that there was more heat on the pad to unsolder it than there was inside of the FET.
What
Well,
would you
no,
call
I
that,
mean,
Pete? 0 to 400 centigrade in how many seconds?
yeah, I mean, you have a good point. If it unsoldered itself, then it would have been about 250 centigrade or whatever, something like
But
that.
briefly,
For a very short time, though. But yeah. So I've got a little something to show. Are you done, Paul?
Yeah. Yes. Great. Go ahead.
Okay. Let me see if I can fumble my way into this window. Let's see. Oh, the UI's changed. No, nope. I want the whole window.
You can share the entire screen, right? This is tabs
Yeah,
up
that's
the
what
top.
there it is. I found it. The entire screen. That's what I want. It's the entire screen. So if I go to here, this is a setup for the Edger system. Can you see my mouse pointer jumping around in a circle here? Okay.
Yep.
So this is a very nice expressive ESP32C3 board. And then this thing over here is a a BMP 388 Bosch pressure and temperature sensor. And this Bosch is particular sensor. It's designed for drones. This is actually the less expensive one, and but the pressure sensor is so sensitive that it can detect a change of altitude of maybe a meter or two. The more expensive one, which is exactly programmatically identical, same interface and everything, it can detect a change of altitude of 25 centimeters, and the temperature sensor has some pretty good specs. It's connected to the ESP32 I2C bus, and this guy is talking via the house Wi-Fi network to this. Oh, wait a minute. Let me show you. This is a close-up of the sensor board, and to give you an idea of how small this thing in the middle is, the sensor. And that little hole right there is to allow the sensing the atmospheric pressure. And this is a plain less than 20 gauge wire, typical like jumper wire, to give you an idea of how teensy tiny this is. And
what's that plastic you got on there?
That's a piece of saran wrap to keep my sweaty fingers from degrading anything. So I can grab this thing, and I'm measuring skin temperature with it. I have a medical situation that causes my peripheral blood flow to go nuts, and so I'm too hot and too cold. And I thought, well, I wonder if I could actually measure this. And so this is kind of the project. Anyway, this is a web browser running JavaScript from a local Node.js instance, running some software we call Aardvark. This system here, this piece of it of the system on the end is called Ant, and those references to Ant that Nick was making earlier. He was describing systems where he's got this basic set, something similar to this, with a lot of different cameras and sensors and so on. Anyway, this is the other side of it, and we've got it set up so that the temperature sensor data can be sent via Wi-Fi to the local area network, and then picked up by code that's running in the browser here. And if I grab this sensor, you can see the temperature jumping up. It's the room temperature in here is about 23 centigrade, and when I grab it, it jumps up into the low 30 range.
Can you fit it under your tongue?
Say that again.
Can you fit it under your tongue?
I could well, actually, it's a bit long. I don't know
Okay.
how. Yeah, I don't know.
Just a thought.
Oh.
Pete, can you go full screen on the browser? It'll look better in the video.
How's that?
That's perfect.
Yeah, and this is a 4K screen. I was hoping it won't blow up the system. So anyway, it's extremely responsive. But the samples are only being captured every 5 seconds. It could be going a whole lot faster. And anyway, this is just a quickie little demo. And next week we'll be we'll be talking about a number of other things to do with this system. But I just thought this might be an amusing demo. Any questions? Okay, well, I will turn off the sharing and turn it back over to you guys.
I have some toys I can show people.
Do tell.
I was just feeling like spending some money, so I bought a reel of the 10-cent RISC CPUs from China. I bought the whole development package, which cost me $10, including 50 chips. And I got a little board. It's got 16K of memory on it, and I got a programmer, and I got a bunch of chips, all for it may have been $11. But it's got GPIO, it's got an SPI, it's got I2C. It's not a bad little CPU. It's a RISC-based machine, and I haven't got it running yet. But for $10, I figured I'll get to it eventually.
Is this the RISC-V stuff?
Yep, I think it's a RISC-2. I haven't got the tools up and running, so I really can't. I got an arbitrary waveform generator with a LCD display that'll put out the 250 megahertz waves of various. It's an arbitrary waveform. You can put whatever. It's got 4K of memory on it, and you can program whatever timing circuits you want.
How many bits in the DAC?
12.
Wow.
And it's so you've got you've got 4 outputs, and then you have a master clock that you can run anywhere from 500 megahertz to 1 hertz, and it's really kind of nice for setting up timing for things that take complicated timing.
Paul, pull your mic down.
Thank you, Carl. So you can store your output data in this RAM and then feed that out to the out to the output at whatever rate you want.
And it's got a 500 megahertz digitally synthesized clock, so you can do some very, very accurate timing. And there's one master clock, and then you've got 4 outputs, and you can change the phase. You can do all sorts of timing things to it, and it has a little LCD display that you can set up and start stuff. And it's there was some stuff that needed some fairly complicated timing, so you start one phase, and and it was neat, so I bought it. And the final thing I got from Trampus, Pete helped me get an XY frame that he was using for pick and place, and I started playing with it, and it kind of got away from me. And does anyone ever played with EDM machines? Electronic discharge machines. It's a way of doing very, very accurate cutting of metal by electronic discharge. And I now have an XY frame. I've got to finish testing it, but it's got a variable current source that'll do 50 amps, and it's a little machining station with X, Y, Z, and a theta head on the thing. So you've got to do the EDM under some kind of liquid, but you get mirror-like finishes and incredibly accurate. So
that's cool.
I will give you updates on that, but it's built on a 24-inch by 20 by 19-inch XY table with that I can use with it's a home built 3D milling machine that I have. I put my own heads on the thing, and it has a controller and a Wi-Fi interface, and I'm looking forward to cutting holes in pieces of metal. But you can do one of the things you can do is to take a syringe and cut a hole which is the diameter of a syringe, because there's no erosion, and you can cut incredible aspect ratios. You can go all the way into a single piece of metal with a syringe. Takes a while, but it's so if you ever want to make a syringe holder, let me know.
Can you put a 2.5 to 3 inch hole in this thing?
Yep.
There are some great videos on YouTube about what you can do with EDMs, about making pretty much hidden stuff with blocks.
Mm-hmm. Yep. It's and so I've got a nice, very heavy 4040 cable, which has, say, 4 axes, and the theta axis is, I got a rotary head, and so the fluid for the EDM goes through the rotary head where the stepper motor would normally drive it. So I can it's coming together quite nicely. But yeah, it's you can make these blocks that one fits inside the other, and there's no visible seam. It's it takes a while, but it's kind of fun. And if anyone's interested in these 10-cent CPUs, I'll give you an update next meeting if I get them going. But I figure, SPI.
That would be interesting to see them.
Yeah, I mean, it's got an SPI, it's got an I2C, it's got a whole bunch of GPIO pins, it's got an A to D converter.
Any idea how power efficient they are?
None.
Okay.
I mean, I know what the spec says, and it's in Chinese, and I can read a tiny bit of Chinese, but
yeah, my wife can translate for you.
Yeah, well, the problem is I don't believe anything they say. So
yeah, that's the other problem.
Yeah, I mean, it gives you a rough ballpark of, it draws something in the sub-milliamp range. This I know. And if you turn it off, it draws a lot less power.
How many pins on the chip?
18. Single wire programming.
Square or just 2 side?
The what?
Are the pins on all 4 sides or just 2 sides?
No, just 2 sides. It's a
SO.
Yeah, just a
what that's called.
Yeah,
small outline.
Yeah, it's one of those, little.
Looks like small outline.
Yep.
Yeah. Those are just about hand solderable. Any smaller than that, forget it.
Starts to get painful.
Yeah.
But as I say, for 10 cents, it's got a built-in oscillator. You can do things like read the value of a pot and put out the value on a I2C pin for 10 cents. It's it's pretty interesting if I can get them to work. The directions are not exactly quite as user-friendly as they could be.
If you can cut and paste into Google Translate, I've had real good luck with Chinese doing that. And Korean also.
Yeah, no, I've had good luck too. It's just
you do have to transpose your grammar a little bit, right?
Yeah.
I mean, to make sense out of it.
Well, I'm trying to finish up the edger stuff, and so I won't let myself play with those as much as I want to until I get my first legitimate release done.
So 2024, right?
It's looking good. I'm getting happy with it.
Did your developer kit / programmer come with a socket for the chip, or do you have to solder?
Oh
it down?
no.
No, you have to
I got,
solder it.
yeah.
Okay.
You know, it's ideal for a little Oshpark board.
Yep.
You know, it's a I rather than taking Pete's approach, which is to build multiple boards, I just have managed to dissuade my guilt problem. I just buy the boards and don't feel guilty.
Do you have the link to that you can post?
Yeah,
Since
I
we're
do.
talking about it, I can put it in the description of the video.
Yeah. Let's see. Yeah, it looked like an interesting thing to, and the price was ridiculously right.
Yeah, with the things turning down a bit, I could imagine they're really giving some deals now. Probably pretty hungry for any kind of sales.
Yeah, it's the Australian guy has a whole video on how to use them.
Davy Jones.
Yeah, David Jones. Yep.
Does he have a locker?
No,
Davy
he's
Jones?
got a hell of a shop.
Yeah.
All right. Other show and tell.
I have a question, maybe a tell. I was just curious if anybody's been working with CAN bus sensors at all.
I've done some work. I have some transmitters and receivers. I did it a while ago with the Arduino stuff.
I've been getting into it and I've had great success with it with Python. Python supports it, and I've learned a lot with the object-oriented programming through it. The CAN message class. If you look through the source code for that, wow, they really get into just about every possible thing you could want in an object there. And so anyhow, I've learned a lot there. It's been going good for me. I'm using a Raspberry Pi with a CAN hat on it, and sending messages back and forth, and have a tester set up. And for the first time ever in my entire career, I found out what an arbitrary waveform generator was and how to use it, and record digitize a waveform and then play it back with various different time delays. And I'm really having a lot of fun with that Raspberry Pi and all this test equipment, and the thing that's slowing me down more is stuff that should be the easiest, which is the serial port, sending messages back and forth on the serial port. And I found out that the Pi serial library, apparently a lot of people don't like it. They claim it was badly written, and they have their own classes that they suggest, but they said the workaround for it is when you open up a serial port to read it, use the in waiting to see if you have any bits rather than the read line or character by character. So I'm learning. I've done a loop back from the transmit receive UART on the Raspberry Pi to the USB. So I send messages back and forth. My next step is to figure out the best way of parsing a serial stream to break the stream apart into different commands, values, parameters, and so forth. So that's the limit of where I've been and where I'm going. So I'm looking for the best way to manage and parse out a serial stream as I receive it.
Well, if you can get it out into Linux land, there are a lot of tools,
Mhm.
tools. Probably the most powerful one I can think of is expect. Expect allows you to specify interaction. So you can basically gather up data going in one direction and then send responses and so on. And it's very, very, very versatile. But there are other tools. There are no doubt libraries within Python, but expect is a real nice standalone thing that you can use.
Yeah, expect is kind of old. It's been around for like ever.
So
Yeah.
How do you spell it?
EXPECT.
I did a Google search and didn't find much.
Well,
It's
It's been replaced
library
with
for
screen now.
tickle.
it's fully debugged, so therefore it's obsolete.
Okay.
Yeah, there's kind of an ageism with software in some cases.
Yeah, you could probably do this in Python, as you were mentioning.
I'm sure there's going to be Python bindings for expect libraries as well. There's Perl bindings for it. There's all
Right.
kinds of bindings for it.
Yeah.
Yep.
Tickle is what it's written in if you want to get into a cool language.
And with the CAN bus, you can actually adjust the head timing and cylinder timing on your engine, which is always fun.
I thought he was going to break into a Tesla or something.
So have
Well-
you transmitted on your car's CAN bus?
No, I haven't gotten that far yet.
Okay.
I did buy the $5 cable from Adafruit. It has the OBD on one end and the DB9 on the other end, which plugs conveniently into the CAN hat that I got from Copperhill Technologies. They have a lot of nice CAN hats or Pi hats, I guess you'd call them. That they specialize in CAN. And in fact, the guy that owns or runs the company, he has published some books he's on it. But they're very nice people, and their boards are anywhere from like $50 to $100, and they work, and they're well supported with Python. But yeah, I'll try the car out too shortly.
If you ever need any serial test gear, let me know. I did lots of serial stuff in my life. I've got a bunch of different serial protocol analyzers and injectors and all that fun stuff.
Sure. Well, thank you.
CAN was originally developed for cars or automobiles and vehicles in general.
Yeah. Yep. And there's a couple different variants of it now. I'm working with the J1939 and soon to be the CAN Open spec, CAN Open version 2. They can coexist, but you have to send like an escape character to allow the CAN Open ones to messages to go through. So I've had good luck with the CAN stuff, and that Python library, the PyCAN and PyCAN utils and so forth, they've worked out really, really well for me. And I was even wondering if that class, the CAN.message class, if doing something like that for the serial data, create your own class and then just assign the string to the class and let the class parse it out. I'm not a Python programmer, but I've learned a lot real fast. And the thing about Python, everything I touched worked. So I feel like I got cheated because I really didn't learn it.
Well, just just get yourself involved in Node.js and the ESP.
If you want to have a nightmare, sure.
Yeah. If you want to see failures, try that.
Yeah, it's we can provide failures.
No, Python was my major language now for over 20 years. So So
I
yeah,
can tell you for automated testing, and nowadays, a lot of people get into the Circuit Python or Micro Python.
right.
Most definitely. I mean,
Python runs on almost everything at this point.
Well,
There's
it
a
runs on every.
library for everything.
I think there's like 1,000 libraries, but everything I've touched worked. I have it running on a Pi Zero. Basically, I have almost one of every Pi that they ever made, and it works on all of them. And I've put the can hats on all of my Pi Zeros, A3s, 3B plus. Um, I have yet to open up the box for the Pi 4, but basically I have one for one of all of them, and they're all working with can hats on them and talking to each other. And the other thing that I've done is I've used the Open OBD, the onboard debugger, and with the processor that I'm working with, the Infineon, I was able to actually flash the load the code into it. It's hit and miss. It doesn't load every time for me, but I was able to use a Raspberry Pi with the Open OBD and use it to burn it. I haven't done any the debugging or the I forget what the other three-letter acronyms are for the actual debugging tool that sits on there too. But anyhow, when I learn a little bit more and I'm more, yeah, go ahead.
GDP.
That's it. Something
Yeah.
like that, yeah.
Or
But,
JTAG.
and it talks to all that stuff. So when I get a little bit more confident and understand, maybe I can help the group out and present something, because it's been a lot of fun.
Yeah. If you ever have Python questions, just drop me a line. I'm more than happy to help you out. I've done it with Paul a few times.
Okay, great. Thanks, Carl. Appreciate it.
Carl's kind of our local expert in Python.
Well, that's nice to know. And it it's very popular. There's YouTube videos and courses, and seems like everybody wants to be a Python teacher on YouTube.
Yeah. Well, the only thing I would say to be careful about is, with a grain of salt, uh, don't don't look at much that has to do with Python 2, unless you know how to convert it to Python 3, because
Yeah.
Python 2
Yeah.
is no longer supported,
Right.
Yeah.
No.
and which means it's full of security holes at this point.
Yeah.
Don't start any projects in Python 2. Matter of fact, to be honest, I probably wouldn't want to go below Python 3.9 at this point.
Yeah. Well, thanks, and I'm aware of that. Everything I have is at that 3.9. Um, it's all brand new. I started it all in the last two months, and so I have even the pip is already been replaced. Instructions I've read said make sure you type PIP3. Well, I found out that when you load the new Raspberry Pi image, that pip is defined as pip3, so you can't you get it confused.
Yeah, yeah. Well, the thing is, though, with pip, you can install with any version of pip, even a version 2 Python one, you can install version 3 code with it.
Hmm.
So it doesn't really matter the version of pip and what version of Python it's running it, it'll install anything, anywhere. So it's just the nature of pip. The thing is, don't do anything with 2 anymore.
Right, sure.
Really.
Yeah, just think of pip as kind of like an application that rides along with the rest of the Python.
Well, it all it is an install environment, a way to install your code, but you tell it the paths, so it doesn't care what version it's installing.
You'll find that Python has a real quick
Learning
browser
curve.
server, not browser server, HTTP server, and so
Yep.
you could fire up a directory real quick and serve it up, and you'll find a number of other good little
Yeah,
utilities.
I wrote a multi-channel HTTP server in Python quite some time ago now that actually acts like it's multi-threaded, but it's not. It uses the channels in the in the kernel select command. So you can just set up multiple channels and it'll just poll between those channels. It's pretty cool.
And if you have any Node.js questions, keep them to yourself. I have enough questions of my own. I don't need your questions.
Well, you won't get any from me. I'm not there.
I've dealt with Node before. JavaScript I'm okay at, core JavaScript, but when it gets into like some of the stuff you've been doing, no, that's not my cup of tea.
Yeah, I've got enough problems. I don't need anyone else's problems.
Oh, I won't do this. I'll just describe it, but I could pop my screen sharing back on and show you how, while that little demo is running, I can go in and edit the JavaScript source code, and it on the fly rejiggers everything, and it instantly is reflected in the behavior of the code.
Hey, Pete, you're describing something that would make a real good AI where it anneals itself and reprograms itself.
It doesn't do any of that. All it does is it updates itself, and heaven only knows how.
No, I'm just saying, like, for instance, I
edge
know
cases.
a couple of companies, John Deere being the big one, that they've used Lua and other things because it can write its own code, recompile it, and reinsert it into itself.
Yeah.
Yep.
Speaking of, I've had a lot of
somebody raised their hand.
I've had a lot of success using some of the AIs to decipher extremely complex Python objects. You know, where you import the introspection module and it doesn't help. You know, and it was real nice to be able to ask a few questions and have it say like, oh, well, this is how you utter a reference to get the data that you want out of it.
Somebody there raised their hand, fellow Jitser.
Yeah, that's me. It's Jamie.
Oh, Jamie.
Oh,
hi.
Hello. I had to join by phone, so I don't know if you could see my name or not.
No, it just says fellow Jitser.
Oh, sorry, y'all. Let me see. Do I have to put my hand down? Lower
That's
hand.
cool.
Okay. No, I just wanted to share the small project I just embarked on at the Forge, if that's okay.
Go for it.
Okay. I just joined as a volunteer, so I'm excited about that and appreciative. But I was made aware of the plastibots that were going to be gutted for parts, so I chose to start a project of rebuilding them using parts that are going to be pulled from those machines and try to improve upon the design using metal extrusion and 3D printed parts. So I'm really interested in maybe finding out others who had been involved with the plastibot building, getting maybe feedback on ways to improve those designs. And I'm also curious about, I think I was told that an Arduino could drive the 3D printer. So it's a new project and I'm just gathering information and trying to figure out how to manage the project. So if any of y'all have any input, I'd be really appreciative.
So that has 4 servo motors, is that correct?
I believe yes.
Stepper motors. So you're probably going to need some stepper motor drivers.
There'd be 3 plus the platter, right? Which would be the 4th.
I think one of the axes uses 2 steppers to control both ends of it. So
There's
3.
actually an Arduino board from DF Robot that's already got the motor drivers on them.
Arduino from DF Robot, okay.
Yeah, several people years ago, RepRaps and Mendel type 3D printers were using the DF Robot board.
Okay.
Yeah, you probably gonna have to write your own code though.
No,
Yeah, don't want
Smoothieware will do it for you. Go look.
Smoothieware.
Yeah, no, it's a real thing.
Oh, that's what it's called, Smoothieware. Oh.
Smoothieware. It's an Arduino-based
chatbot.
yeah, no, it's an Arduino-based controller for 3D printers.
Oh,
Yeah, so
okay.
so at the Forge there was the Build the Mini Mill workshop
Mm-hmm.
some number of years ago or months ago, and so that it's the 3018 Pro CNC machine.
Mm-hmm.
The controller on that is Gerbil, GRBL.
Yeah, that's the language.
Yeah. So it's a CNC controller. I just bought one. So it's a 3-axis controller, and it was like $35. And so that would maybe be a good choice for doing your motor control.
Okay. And that's the 3018 Pro CNC machine you said.
Yeah, but it's just
Okay.
the motor driver controller.
Okay.
I'll post a link to the one I bought.
Okay, great. Thanks.
It was $37.54.
Okay.
I've got to head out, folks. So I'll say goodnight.
Night, Pete.
This is Pete. Yeah. Bye-bye.
Good night,
Later,
Pete.
Pete.
Thanks.
Good night, Pete.
We'll talk
Good night,
about it when
Pete.
you're done.
Any other questions or?
Paul, what's this Amazon thing?
It's a 3-axis CNC controller
Yep.
that you can run a 3D printer or a CNC machine off of. It's got inputs for limit switches and stepper motors and emergency shutoff and
I just wanted to put a little description in there so when I put it in the video description, people know what the hell the link's for.
okay.
This is a Arduino-based controller. It's got 5 controllers and an ESP32 and has an LCD display that plugs onto the thing. So you can do a lot with the Arduino stuff.
Oh, okay. Great.
Yeah, I've been working on 2 projects. One is not electronics at all. It's outdoor vents for my fans in the bathroom. As it turns out, the pipes
Just
are
went into
3
the
inch.
attic.
No, they're not. They go to the bathroom and they go out the side wall. The problem is the ones they put in, they use 3-inch pipes, which are non-standard. They're really hard to find. And almost all of the new vents you would put on your house are made of this horrible plastic, which in the sunlight falls apart in 4 or 5 years, which is what happened to mine. So that's what I used Open SCAD for, is to redesign these things. I'm going to make them out of aluminum. And I just started cutting some of the aluminum today. So this is the base that goes on the wall. Another project is, I mentioned this a long time ago. I have a USP, and it keeps burning out the SLA batteries. And the reason why
UPS.
UPS, I'm sorry, yes. I don't know if I'm going to stretch without not pulling out the microphone, the headphones. So this thing is what the batteries go in. And there's no ventilation except these 6 side vents. No fan, nothing. There's a fan for the electronics, but not for the batteries. That's why these batteries are frying. So I completely redesigned it, put in an L-shaped bracket, remove this thing, and I'm going to make this thing lithium ion. The only batteries. So the only problem I have is, well, there's two problems. One is it supplies 40 volts. I need 42 volts in order to charge 36 volt lithium ion batteries. That's what the BMS is going to need. So I need a step up a boost converter for that. The other problem is that there's only 2 wires, and all BMSs are going to expect 3. One ground, right, for both output and input, one charge and one output. The charge is very low current. It's like, what, I don't know, an amp or maybe less. You don't really charge lithium ion batteries at a very high current. But how do you switch them? And I'm going to have to dig into the electronics of this thing and figure out, are they switching a relay back and forth? How are they doing this for the SLA batteries? So, because I'm pretty sure they've got to do something like this for the SLAs. Matter of fact, I don't get any voltage, any charging voltage, unless I connect the SLAs to it, and then the charging voltage kicks on. So I'm pretty sure
that seems safe.
Yeah. So I'm pretty sure there's a relay in there that says, okay, if when I'm reading 0 voltage, it's because I'm supposed to be supplying it voltage, right? To run the inverter in